Yes, ma'am.
Yes,
Can
ma'am.
you see my
Yes, ma'am.
presentation?
Yes, ma'am.
Okay. Okay.
Yes, ma'am.
Okay. Yeah. So today we will be, discussing the concept of spatial data. This is block two of your first course. Let me put it to full slide mode. Is it okay?
Madam. Yes, madam.
Yeah, okay. So, just a minute, something is going wrong at my end. Yeah. So this is the second block of the first course, concept of geospatial data, which we will be discussing today. And as you had one session yesterday with Professor Deshmukh, you have already known about the overview of geoinformatics, and this particular course, that is Introduction to Geoinformatics, unlike other courses in the first semester, it is of 6 credits. Remember that. Your second course is of 4 credit, and then third is also 4 credit. But this is of 6 credits, so it has got more units. So today we will be discussing concept of geospatial data, that is block 2. Now this block 2, that is the part of your volume 1, that is Introduction to Geoinformatics and Geospatial Data. It has been packaged into two, it consists of 2 blocks. So this is the second block of volume 1. Fine. You must have got your SLMs, hard copy of SLMs. It looks something like this. Now it is time to open up your SLMs because the exams for the PGCGI, except for MSc, rest of the students have to appear for the term end that is scheduled in December. So now it's time to open up your SLMs. So this particular block, it is comprising of 6 units. They are like this: uh, Introduction to Geospatial Data, sources of raster data, sources of vector data, and then overview of data analysis tool. It has got 2 parts, that is unit 7 and unit 8. And the last unit, that is unit 9, that comprises overview of geospatial programming languages. So today we will be discussing all these units. See, again, I want to reiterate that uh, your counseling sessions, we are not supposed to tell you word by word, or we are not supposed to take a class as it happens in the conventional system. One block is given 2 hours time. So we will be discussing all these 6 units in these 2 hours. So if any one of you have read these units, you can ask your query. Otherwise, I will discuss the salient points of these all these units today. Fine. So this is your unit 4, that comprises of data information, precision, accuracy, kinds of data, and then so the
Ma'am,
objectives of this particular unit
excuse
is
me,
that
ma'am.
you differentiate between the data and information, and then defines geospatial data and information. And then we will also discuss about different kinds of data. So now, one of you can unmute your mic and you can tell what is data and what is information. See, what I mean to say that our interaction should not be mere passive listening. All of you are in your different fields and all of you are aware of these words in your day-to-day life. So I will expect any one of you to please unmute your mic and tell what is data in the common language and what do you mean by information. Any one of you.
Ma'am, excuse me, ma'am. Just wanted to repeat here. See,
Yeah,
this is a block which is almost same for PGCGI program and the PG Diploma and MSc program. So, but there is slight difference in the way the units have been organized, meaning that in the PGCGI program, these sources of data and the software are given in one unit each. But in the case of this PG Diploma program, this are divided into two different units. So one unit for sources of raster data, one unit for sources of vector data, and the
yeah,
sources
yeah, yeah.
and COTS and FOSS. So don't be confused, but you can listen to this madam's session and enjoy the session. All the best.
Yeah, yeah. I just forgot to tell that for PGCGI, the units are organized in a different manner. When I will come to that particular unit regarding geospatial data tools, like here it is part one and part two. But in PGCGI, it is one unit that is geospatial data tools. Okay. So I'll tell you there because there is bit difference in organization. And for PGCGI, your first course that is only 4 credit, and for DGI it is 6 credits. Thank you, Professor Deshmukh, for pointing it out. I don't know, something is yeah. So any one of you please unmute your mic and tell us, otherwise I will continue. uh, Anyone?
Uh, uh, Hello, ma'am. Good morning.
Yes.
Ma'am,
Yeah, yes,
actually,
Nisha.
data is what we get information for any specific information. Is basically when we collect any specific information, then it comes in a form of data.
Yeah, information that comes good, it comes in the form of information you get basically as raw data. So it is,
Yeah.
I mean, represented by some digits or some letter or symbol. But when you derive some knowledge or some
Some knowledge about, yes,
explanation or
about that
inference,
specific, yeah. So then
yeah,
it
then
comes
it
in
is known
information.
as information.
Information.
Yes,
Yes.
good, good. Thank you,
Thank you,
Nisha.
ma'am. Thank you, ma'am.
Now, there are certain terms which will come again and again in these units. So, one is geographic, geospatial, and spatial data. Now, let us differentiate between these three terms. The first one is geographic data. Yeah, geographic data. This refers to any data that is related to the surface of the earth. Okay, and then geospatial, this refers to the related features. And then you have location as one of its attribute. That is, you have the information about the location. So then that data, that geographic data, that becomes geospatial data because you have the information about its location and other attributes. And then spatial data, this may refer to any data that is related to planet, cosmos, and or human body. So that is the basic difference between these three terms. Mhm. We have already discussed that information describes like data you got as a fact, as number or symbol. Now, this information means it describes that particular data. And then one more term is added to information, that is geospatial information, to be very precise. This can be defined as information regarding the location and the names of the Earth's features. Because that word geospatial has come into. So this geospatial information, this supports a very wide range of activity like business, government, and community related benefits. This particular information is used by decision makers that you will see in your lectures onwards. So now difference, that between data and information already discussed. So how are you able to convert this data into information? Either a human or a machine, that is computer, that is able to convert this data into information. So suppose you are looking at some satellite imagery. Visually also you can interpret. Otherwise, you have got digital interpretation methods which are done by using some software on the computer, and this will be able to convert that data into information, which already Professor Deshmukh and Rohitas, they must have told you, they must have shown to you in your practical sessions. So the example of geospatial information are thematic maps and topographical maps. And geospatial data are what? Satellite images and aerial photographs. Okay. Now there are again two terms, precision and accuracy. In your day-to-day life, you must have heard these two terms, precision and accuracy. And often these two terms are used interchangeably, because, like many times, instead of accuracy, you say precision and vice versa. Now, exactly what is precision? These two terms are used not only in this context, they are used wherever the data is concerned. So, precision means the repeatability of the data. Suppose you are getting a figure of 10 for some data. Again and again, you are getting 9.9 or 10.1 near to that 10. That is absolute figure that becomes precision. That is what? Repeatability of data. Accuracy, another term that refers to how well they were measured, recorded, converted, manipulated, transformed, and presented. That is, in other words, accuracy refers to the closeness to the true value. Suppose the true value is 10. Now, uh, how close is your the value which are measuring, how close it is. So now that becomes accuracy. These two terms you can understand well in this figure. That is accurate. I mean this sorry, this particular figure, I mean, I'm showing by my pointer. Neither it is precise nor accurate. Okay, but here it is precise. You have repeatability of the data, but the true value is here. You don't have accuracy. You have repeatability, but no closeness to the true value. That is, they are precise but not accurate. Now, here they are not precise because you don't see any repeatability of the data, but they are close to the true value here. So not precise but accurate. Now here it is both precise and accurate. Repeatability is also there and closeness to the true value is also there. I hope you must have understood. If you have any questions in between, please you are free to interrupt me and ask the question there and then. Now, let us move forth with this discussion. Kinds of data. See, whenever the data is concerned, there are two types of data, primary and secondary data. I think many of you must be aware of this. Primary data is that data which is collected by the first hand field work. Like you go and do the field work or survey, some GPS survey or aerial photography or satellite remote sensing. These are all primary data. But when you refer to the data which has been published in somewhere, or you take it from some published sources such as official statistics and then like census data, you take that data. So that becomes a secondary data for you because it was gathered by some other agencies, and then you have, taken, or you have used that data. That becomes a secondary data for you. Now, we were talking about geospatial. Now, information, likewise, you have geospatial data. Geospatial data, it has two basic data types which we use as geoinformatics tools. One is spatial data, and another one is non-spatial data, or you also call it as attribute data. Spatial data or non-spatial data, which we also call as attribute data. Now, apart from this spatial, non-spatial, you have other kinds of data like temporal data, then metadata, measured data, inferred data, imported or converted data. And all these types of data which are listed on your screens, they can be, they can be both either spatial or non-spatial or both. Again, when you come to, oh, there are few people to be admitted. Yeah. When you say spatial, so as we discussed before, then when the word spatial comes, it has reference to the location of the earth, on the earth. And it also should have explicit relation between the geometric and the attribute aspects of the information that is being presented. It should have it should be organized in a particular theme, and it should have features such as area, line, or point. We'll come to that further. Now, when you come to examples of spatial data, see, spatial means something which is related to the space, or you have some locational data. So when you talk about the location of the rain gauge, what is it? That is spatial data because it is concerned with some locational data. When you talk of some submerged area under flood, again, this area that is referred as spatial data. When you talk about some route delivery truck takes, again it is spatial data. When you talk about some damage by forest fire or some tourist place, again it is referred as spatial data. This spatial data that refers to the locational information that can be divided into two basic categories. Excuse me. That is vector data and raster data. When you talk of vector data, it means or it describes the discrete features like location, some location of some customer location, and then streets and some land use. But when you talk of raster data, it represents continuous numeric values such as elevation and continuous category like vegetation types and water. So be very, listen very carefully. The spatial data that can be of two broad categories, that is vector and raster data. Now again, spatial data. See, it might be confusing to you, but let me clear it. We started with primary and secondary data, and then I listed many types of data which can be spatial and non-spatial. Now, as discussed earlier, the spatial data, it is also having primary data and secondary data. Primary, again, it can be raster data, it can be vector data. Secondary, again, it can be raster data, it can be vector data. So the example of raster data, that is digital satellite images and digital aerial photographs. And vector data is GPS derived data or ground survey data. And what is secondary data? In context of raster and vector, when you have scanned aerial photographs or satellite images, or when you have scanned films and paper maps, okay, and secondary vector data, when the data is converted from the raster data or digitized vector objects from the map and other sources, that becomes secondary vector data. When you talk of vector data, it is represented in the form of line, points, and polygon. I will show you the as we are discussing. I expect that all of you must have opened up your SLMs, must be going through your SLMs, because if you listen to this very carefully, believe me, at least 30 to 40% will go in your you will imbibe 30 to 40%, and when once you read your unit, you will understand 60 to 70%. At least for the first time you are listening to these terms. So open up your SLMs and try to correlate things, because many figures are given there. I'm going only through the salient points. So vector data, it can be, which is, yeah. Vector data, it can be represented in the form of lines, points, and polygons. When you talk of lines, it is like the points are connected, it becomes line arc or line data. Point, that is, or you also call it as node data, and polygon, that is closed boundary, the connecting lines, they enclose an area, that becomes polygon. So what is the fundamental building block of spatial data? That is point data. And polygon, what, as I told you, it is the enclosed, that is closed figure, that is made up of many vector lines, they are joined. Suppose if you want to show some lake or some political boundary, so you have these connecting lines, and that becomes a closed figure or a polygon. So this is like this. And raster data, uh, we discussed that vector data, you can represent it in the form of point, line, and polygon. And raster data, it uses grid dimension. Like one small grid is used to record the information. See, See, you take your photograph with the help of your mobile. When you zoom that picture, you see small grids. You see small grids or pixels. So this information, this raster data, in this case, that information is stored in each grid. Okay. So in case of digital satellite image, it is a form of raster data where the smallest individual grid unit that stores the information, and this is the small grid that is the building block of an image. Okay, as I told you in this digital photography. Now here you can see what I was discussing in last 3, 4 slides. The top row that shows you the representation of the vector data. Point, line, area feature, that is polygon, and then this topography can also be represented like this. And the row below, that is the representation of the raster data. One grid that gives you point. Then these connected grids that tells you about the line. And this area, this the end. I mean, these joined grid, they tell you about an area, and then elevation or topography can also be represented in this raster. I mean, in this way, okay, in the form of grid. Hope this is clear. The top gives you the vector data, and the beneath figures, they give you how the raster data is represented in form of point feature, line feature, area feature, or the topography can also be represented using this vector, I mean, vector data and raster data. Again, the same thing. These are the real world features. And how do you represent in vector data? Like this, by line, and then you have this polygon. Okay, here your water body is represented in the form of polygon, and your marsh is represented like this, and forest is represented by a polygon. When it comes to raster data, these are the connecting grids. Okay, the same thing here. Same thing in the raster data in the form of grids. Now there is one more term, non-spatial. What is this non-spatial or attribute data? We also call it as tabular data. See, there are certain terms which are used to describe the data. Suppose you are sitting in your office. Now, what is the material used for the construction? What are the color of the walls? Or the related data connected with that building, that becomes non-spatial. Or if you have installed some rain gauge to measure rainfall density, so what is the type of rain gauge? That becomes attribute data. Okay, that describes the data. Okay, that becomes attribute or non-spatial data. Now there were other terms which I had listed: temporal, metadata, and all this. So they can be spatial, they can be non-spatial. Let us discuss about them one by one. Temporal. When you say temporal, what does it mean? Related to time. That represents the state in time. This temporal data, where can you use that? When you describe the land use, or you describe some urban sprawl, or some cropping pattern, or some disaster. Suppose you talk, just an example for temporal data. 1960, the Delhi, the state of Delhi was like urban sprawl in Delhi was like this. Now 1970, it is like this. So this data you are describing with the time. Okay. Suppose you talk of cropping or land use. Land use was in 1940, it was like this. 1960, it is like this. So when the data, it is described with the time, that becomes temporal data. Okay. So this type of data is very useful, as I told you, in land use, natural disaster. Suppose this is the flooded area. Prior to flood, it was like this. So again, that is temporal data. Then your meteorological data. Again, it temporal, because you will say yesterday the weather was like this, today the temperature is this. That is concerned with time. Temporal. Here you can see 24th September, 25th September, that becomes, this is a figure from your SLMs, and it describes the life cycle of a cyclonic storm that took place in 2021, how with time this storm proceeded. So that is temporal data. Again, one more figure, again from your SLMs. 2005, 2006, 6 and 7, 7 and 8. So this is multi-temporal remote sensing data sets. This is showing the change in land use and land cover during this particular period. Now another word, that is metadata. Metadata means data about data. Okay, that means information about the data. Suppose you have some data. Now, what is the accuracy of the data, from where this data was sourced, and what were the methods of collection? So, all this information, that is known as metadata, or we call it as information about data. Measured data. This is what? This is physically collected data by surveyors, that is known as measured data. Inferred data. When you calculate the data from other data, this is known as inferred data. Example, types of crops in a given field, which are inferred from the magnetic radiation reflected from the field. Then imported and converted data. Imported is also known as converted data. So this is all about the types of data. Now let us come to sources of raster data. Again, here I want to repeat that for PGCGI students, there is one unit, that is raster and vector data, both are combined in one unit. Now here for DGI students, PG DGI students, there are separate units on raster and on vector data. So fifth is raster data and sixth is sources of vector data. This is the structure which you will see in your SLMs. First, we discuss about the raster data and its types, and we discuss about the sources of satellite images and then sources of digital DEMS, that is digital elevation models, and then sources of derived raster data. So for those of you who are PGCGI students, there is additional information. So here you may find PGCGI student may find some additional information is being discussed. Okay. Now about the learning outcomes. See, whenever you sit with a unit, don't start reading. Uh, before going through these learning outcomes. Pedagogically, these units are designed by IGNOU, and lot of research has been done on this from last so many decades, that when a learner is studying by him or herself, first of see, there is a teacher in a class who tells, today we will read this, you will discuss this, but here you are in isolation, so called. So when you self-study the material, it is very important for you to go through these learning outcomes, because that tells you what are the outcomes, what do you expect after reading this unit. Okay, so that becomes clear in your mind. Okay, when I read this unit, I will come to learn about this, about this, about this. So when you read the entire unit at the end, you will find that there is a column known as summary. So even you go through the summary, so that you will understand what have you learned. Have you understood that was mentioned in the learning outcomes? Are you successful in imbibing those learning outcomes? And you go through the summary. Have I learned this? Have I understood this? So it is very pertinent for you all to go through the expected learning outcomes as well as the summary that is mentioned at the end. Don't think that only it is given for the sake of mentioning in the unit. It has very strong pedagogical implications. So regarding this unit, after discussing or after studying this unit, you will be able to describe various types of raster data. Sources of primary raster data, then you will be able to list sources of digital elevation models, and we will also be able to know about the sources of derived raster data products. See, already I have discussed. See, this is how the raster data is represented in the form of grid, in the form of line, in the form of area, and this area feature topography. And this is the smallest building block of any raster data, and we are just repeating it. Here, the vertical, uh, these vertical rows, I mean vertical, that is known as columns, and this horizontal, they are known as rows. So when you read this data, this is column 1, this one is column 2, this one is column 3, and this one is column 4. Fine. And this is row 1, row 2, and row 3. And the smallest, that is known as grid or pixel. Okay? Pixel also, I mean, normally we call it as pixel. So this is the smallest building block of raster data. We have already looked into this particular figure when we were discussing the earlier unit, that raster has primary, secondary data, and vector also has primary and secondary data. Further, the examples of raster data types, they are digital satellite images, aerial photographs, and space shuttle images, and scanned films, hard copy maps that become secondary raster data, and DEMS, that is digital elevation models. So let us discuss about the primary raster data. All these satellite images which you see, the aerial photographs or space shuttle images, they are what? They are primary raster data. So whatever data you get from Earth orbiting satellite, they provide vast array of raster data, and which are used as input for extracting information. There are thousands of man-made satellites that are going around the Earth, and they provide data for various applications. So these satellites are known as Earth observation satellites. Continuously, they collect images from a variety of sensors. You have a session on the types of sensors also. So these images are collected by a variety of sensors that are placed on these satellites. Okay, so this digital aerial photographs. This is also another common example of raster data.
Quick
And
question, ma'am.
when the corrections, see, aerial photographs, they need many kinds of corrections, which will be discussed in later sessions. So these corrected aerial photographs are known as ortho photographs.
Quick
Okay.
question, ma'am.
Yeah, please.
Ma'am, what about the drone? We are now using drones, right? That is also a aerial photograph.
Yes. See, remote is what your this mobile camera is also, because you are taking from a far off distance. So whatever photographs you are taking from a particular height, like drone, that is a kind of aerial photograph. Okay,
Okay, thank you.
just a minute. I don't know, a very small screen I'm getting on my, as I'm telling you. Is it okay if I don't put it on full screen? Is it okay for all of you?
Yes, ma'am, it's okay.
Yes, ma'am.
Okay, fine. Because I don't know, I'm getting a very small screen on my. this thing. So that is also a kind of aerial photographs. And these ortho photographs, which I told you that after correction, this old aerial photograph is known as ortho photographs. So these ortho photographs have been in use since long. And further, we will discuss about geospatial analysis tools or software. So these tools, what are these tools? You don't have some hammer or some this thing spade. Tools means softwares which you are using. Okay, so they have made it much easier to produce digital ortho photographs, and they are all stored as raster films. So the photographs taken by astronauts during their space shuttle flights, they are also source of raster data, and then digital photographs taken by astronauts, and then I mean, they see in your SNMs there are various links that have been given wherein you can download these digital photographs. Okay, this shows digital data from Earth orbiting satellite that provides raster data, which is used as input to GIS. Now, this is secondary raster data. There, lost. Just yes, what I will discuss.
वो एक सामान ले आएगा आपके लिए शाम तक उसको देख लेते ना बिग बास्केट पे अभी ले आएगा वो 2 घंटे में
You are all requested to please mute your mics. आप अपना mic muted रखिए, please. Now there is another term that is known as digital elevation model. Have you heard of this term earlier? Digital elevation models or DEMS. Any one of you?
Yes, ma'am.
हाँ, तो please explain.
Yes, ma'am.
Yeah, please आप बताएंगे थोड़ा सा? What do you mean by digital elevation model? Okay, fine. रहने दीजिए. I will explain. See, DEM, it is the most, yeah, sure. Someone
Ma'am,
of you.
this is the method of 3D representation of 2D this digital model.
Yes, good, very good, very good. So this is the 3D representation, and this is the most versatile example of raster data. See, in case of grids, you simply contain the location X and Y, that is latitude and longitude. But when this particular thing comes, elevation, that is Z value, that then you can represent this in this 3D model, that is digital elevation model, and it is used in various topographical applications. Okay, and they represent like these topographical surface, they can be very well represented by these DEMS. So both raster and vector data can be overlaid on DEM, and then they provide a more realistic relationship between the data and the underlying topography. So this 3D GIS, I think yesterday you must have heard about 3D GIS. They are based on this DEM. I mean, in 3D GIS, you require a DEM as or digital elevation model as one of the important layer. So this was about DEM. The next. Now we come to secondary raster data. So when you scan some image or some paper map, that becomes secondary raster data. Okay. You have a hard copy of any map, aerial photograph, that becomes a scanned copy. So that becomes scanned image or secondary data. And then one more term is derived product. What is derived product? Again, this is generated from the primary raster data, such as satellite data. And these aerial photographs and satellite images, they are derived products. Uh, so let me give you example of some commonly generated products like land use, land cover maps, vegetation maps, and then products related to groundwater potential. They are all derived products. Now, let us come to an important, everything is important, but yeah, this one, sources of satellite images. We will discuss about this. From where you can get the satellite images. First one, this I will just skip. It is general. First one is Bhuvan. That is ISRO's Bhuvan portal. So in India, we can acquire remote sensing data from National Data Center, that is NDC of NRSC, that is National Remote Sensing Center of ISRO. Its headquarters at Hyderabad, and in your SLM, this link has been provided from where you can download this remote sensing data. So it is a geo portal of ISRO, and it showcases India's imaging capability in multi-sensor and multi-platform and multi-temporal domains. And you know, this portal, it is a sort of gateway to explore and discover virtual Earth in 3D space. As you have Google Earth, you can sit here in Delhi and you can browse and you can reach New York and anywhere you like. So this is our own geo portal, or I mean, it is virtual Earth in 3D space. Yeah, next source of we are discussing about the sources of satellite image. Next source is NASA or USGS Landsat program. So you have this NASA, that is, I hope all of you are aware of NASA, and USGS, that is United States Geological Survey. So they have a Landsat program, and they provide longest continuous space-based record of Earth's land. And this Landsat data is used in various ways in decision making, and know about the Earth resources and environment. And it is a very dedicated program for the users. And a link has been provided in your SLMs. So this is the screenshot of this Landsat program, and links from where this Landsat data can be downloaded. It is provided in your SLMs. It's given here. Now next, USGS, that is United States Geological Survey. They have Earth Explorer data portal, and it is one-stop shop for obtaining geospatial data set, and it has got extensive collection. So this is screenshot of this USGS, where you can get different kind of data, and you can enter your search and you can get the data. Next one is Copernicus Data Space Ecosystem. Now, this satellite remote sensing data from Sentinel 1, 2, 3, 5P, they are all available. They can be downloaded from Copernicus Open Access Hub. Previously, it was known as Sentinel Scientific Data Hub, and it was launched, the new one, this was launched in January 23. So this is also one site from where you can get the data. Then Alaska Satellite Facility, that is ASF. You have this and this it is a part of Geophysical Institute of University of Alaska Fairbanks, and it provides services to researchers. You have downlinks, processes archives, and and it also distributes remote sensing data to scientific users, and it is dedicatedly committed to provide highest quality data. So here, this one also, and then next is Vedas Geoportal. What is this Vedas Geoportal? The full form of Vedas is visualization of Earth observation data and archival system. It is the geoportal of SAC, that is the Space Application Center based at Ahmedabad of ISRO. Okay, and you can use this data to, this data, it can be visualized in both 3D and 2D. And this has been developed using advanced tools and technologies such as satellite remote sensing, geographical information system, and geoprocessing. And Vedas, it depicts vast and varied information available at SAC. And it also hosts processed data from Moon and Mars. Now, this is the screenshot of Vedas geoportal of SAC, of ISRO, and you have various kind of data that can be downloaded from here. The next, and apart from this, there are other sources to download raster data, which are given in your SLM. The links are given. All this mentioned here. Digital Global Open Data Program, Geo Airbus Defense, NASA's Worldview, and NOAA class. So there are other sources also, which you can read in your SLMs, because we don't have much time to go through all this, only 1 hour left. Now let us look very quickly at sources of digital elevation model. You know DEM, it is a simple form of digital representation of topography in raster form. So you have, users, they can obtain DEM data, which I will be discussing. First one is Cartosat DEM. As we have mentioned in the earlier section, that ISRO Bhuvan Geoportal, it hosts variety of data, and it includes DEM also. So there are various versions of Cartosat DEM which are available in that portal, and you can download from there. So these DEMs, they have been derived from a series of satellite, Cartosat satellite of India. The next source wherein you can download uh, DEMS is Shuttle Radar Topographic Mission, that is SRTM. So in 2000, this space shuttle endeavor started, and this on I mean yeah, in 2000 the space shuttle, it started, and then SRTM, that is part of it. So it has got two active radar sensors, that is SIRC of NASA and SAR of DLR with ASI participation. So SRTM remote sensing mission, as I told you, it has got two active radar, and this venture, it is a joint project between NIMA, that is National Imagery and Mapping Agency, and NASA, that is National Aeronautics and Space Administration. And the main objective of this SRTM is to produce digital topographic data of Earth's surface between 60° north and 56 degrees south latitude, with data points located every 1 arc second, that is approximately 30 minutes on latitude, longitude grid. So this is Cartosat DEM, how the screenshot, that is Bhuvan's from Bhuvan's portal. And this is SRTM DEM of 30 meters, this left one, 90 meter, this one is 30 meters resolution, and this is 90 meters resolution of this Udaipur city. Okay. Now, other sources of DEM. We have seen SRTM and Cartosat. The other sources are Aster DEM. Aster means full form uska hai, this advanced space-borne thermal emission and reflection radiometer. So these Aster and GDEM, that is global. This one, somebody wants to, yeah, a global digital elevation model. These products were made available by Land Processes Distributed Active Archive Center, and 30-meter DEM product is available in GeoTIFF format. And the next one is ALOS Pulsar. These products are available on the website of ASF, that is Alaska Satellite Facility, which we discussed just before. So this is Aster DEM, and this is ALOS Pulsar DEM of the same Udaipur city. Other sources of digital elevation models are Copernicus DEM, which I discussed just now about Copernicus project. So this was made available in use in 2019, and it will be available, it will be maintained till 2026, and it provides three different images at three different instances, as mentioned here: EEA10, GLO30, and GLO90. And then this GTOPO30 DEM. This is also known as global DEM. And then there are other examples also which have been mentioned in your SLMs. Okay, I will not go into detail into them. These are other sources, and one of them is Natural Earth. Now, this Natural Earth, this is public domain where map data set are available at many scales, and it is supported by North American Cartographic Information Society. See,
Excuse me, ma'am.
yeah.
Are the sources you have mentioned for the DEMs are freely available, or there is any cost associated with it?
They can be both. Some of them are freely available and some of them are paid. So that depends on what kind of data you are downloading. Okay. I'm not going into detail because it is already 12:15. Now we will discuss sources of derived raster data products. What are the sources? As I told you that this raster data can be derived from ISRO's Bhuvan Geo portal. So ISRO's Bhuvan Geo portal is very, very significant. The data products, they include thematic services, weather services, ocean services, disaster management services. So just in very short, what are thematic services which you get from Bhuvan portal? So It enables the users to visualize thematic information which are critical for development activities like groundwater potential zones and groundwater recharge zones, crop assessment, land cover and land use, then weather services. They provide information about disaster management support and village resource center. And then ocean services, they showcase potential fishing zones and contain information about distance, direction, and depth of potential fishing zones, which are of use to common people. And then they also are committed to provide disaster management services for major natural disasters. You can get data using satellite and aerial data, and in more detail it is given in your SLM, so you can go through your SLMs and read about all these services that are provided by this Bhuvan portal. And there are other services also like humid, that is hydrological unit model, and then time lapse. One can have time series visualization of geospatial data. So that is also there, which you can go through. So this shows various. This is the screenshot of Bhuvan, and here you can see the overview of ocean services, uh, and the various links are also given. And then you can have derived data from Veda's geoportal, which I discussed just now. Then next is Modi's product. Modi's means moderate resolution imaging spectrometer. So these products, they are used by in many areas, including oceanography, biology, and atmospheric science. You can see these products on your screen, which you can get from Modi's cloud product and atmospheric profiles, aerosol product, and then land cover product, thermal anomalies, and leaf area index when you require for vegetation, and then this chlorophyll A concentration. So it provides varied products in various disciplines. So this is also very significant for the data. And then this SMAP, that is soil moisture active passive. This is again very important Earth satellite mission. This is designed to measure and map the Earth's soil moisture and freeze and thaw state. And because this helps you in understanding terrestrial water, carbon, and energy cycles. And then NOAA, that is National Oceanic Atmospheric Administration. This is a mission to help you to understand and predict changes in climate, weather, ocean, and coast, and to share that knowledge and information with others, and to conserve and manage coastal and marine ecosystem and resources as nations authoritative environmental intelligence agency. So many data products are available at portals, NOAA's portal and NESDIS, that is National Environmental Data. So you have many sources which we have been discussing since last 15-20 minutes. But what is important for you? There are certain cautions. You cannot keep on downloading any data from anywhere. There are some cautions which you need to understand. What are these cautions? Other sources are also there in your SLMs, which you can read. Now, what are these questions? I will come directly. There are 3, 4 more portals which I have not discussed, but let me come to the questions. So, in order to download, you should be aware which kind of data you require for your work. First one is the question is that you should be aware of the accuracy and uh, quality of the data and the data products which you have accessed. And then you should know about the accuracy and the appropriateness of the administrative boundaries of the study area or the state or the country, if any. So you should be very much be careful about the accuracy, and very important, the terms and conditions of the usage of the copyrighted data. And then another one is terms and condition for the reproduction and distribution of the data. And you should have appropriate, I mean, whenever you use some data, you should give some appropriate and formal acknowledgement and citation and credit for the source. Okay. So that is very important, not only in data, anywhere. See, now you have to be very careful about copyright and related issue, plagiarism and a related issue. All of you know that. So whenever you use some data, you publish some paper or you give some report, you should be very careful in mentioning from where you have got that data, and you should thankfully acknowledge the source or the person for the data. Now, the sixth unit is raster data. Sorry, vector data. We have already discussed about the raster data, their sources, and from where you get those data, and what are the links and what are the cautions. For PGCGI learners, this unit 5 and 6 are together, but for DGI learners, they are separate units. So this particular unit 6, we will discuss about. We will discuss about sources of vector data in unit 6, and then primary data source, secondary data source, and as we discussed earlier, that in case of raster data, we will discuss about data sources, ISRO's Bhuvan portal, and other sources wherein you can get vector data. And again here, the major learning outcomes that you should be able to describe primary and secondary vector data, discuss about various sources of vector data and data quality. So these are the learning outcomes. As I told you, see, raster data, it requires more space as compared to vector data, because the data is in the form of grids and you cannot modify raster data at any point. So the vector data is more popular form of representing these features in GIS. And vector data, as we have discussed, you represent this data in the form of points, lines, areas. Okay. So when you have to tell about some location of a, say, school or a college, you can give a point. But see, one thing again I will repeat. Not, it depends on the scale of the map. If your scale of the map is very small, like in case of India, you will represent that college, school, university in a form of a dot. But when you have a bigger scale, suppose you are working on a map of Delhi, in that case, IGNU will be represented in the form of some polygon. But when you are looking at the map of India, IGNU will be represented in the form of point. I hope you understand that. point, line, polygon. So it depends on the scale of the map. Okay. So this we have already discussed. This table, it's very much familiar to you. I will not go into detail. So primary vector data sources are Global Navigation Satellite System, that is GNSS. This information is very frequently used in data analysis tool to record the location of the surface features and also to refer data set as per Earth's coordinate. So GPS handset, the data from the GPS handset, it is the, I mean, very, it is primary, used as primary vector data. Then derived information, this can be clubbed with other system and as communication devices. So that is derived data. And ground surface data, that is data collected from the ground or ground truthing. Secondary data, it refers to digital data products converted from primary raster data, which I discussed. Primary raster data, when it is converted to a secondary vector, to vector data, it becomes a secondary vector data. Now, these are the various sources of vector data. ISRO's Bhuvan Geoportal, Survey of India, National Atlas and Thematic Mapping Organization, Geological Survey of India, FAO, Geo Network. We will discuss about them one by one.
Ma'am, can you back just one slide back?
Pardon? Yeah, please.
The previous slide, ma'am.
Previous slide. Yeah. These were the primary vector data sources. And when you convert your primary raster data to vector data, that becomes secondary vector data source. And the common products are land use and land cover maps, groundwater potential zone. So these are all secondary vector data. Clear? Now, we will discuss these vector data sources one by one. First one is ISRO's Bhuvan portal. See, there are many sources of vector data which are freely available. And some are available at some cost. I mean, not all of them are freely available, at some cost also. So when you download this data, you should be very careful regarding their appropriateness and accuracy. Okay. First data source we will discuss, that is ISRO's Bhuvan Geoportal. This we are discussing. Okay. So this ISRO's Bhuvan Geoportal that it hosts many thematic products that includes vector database also. Okay. And this database that is visualized, it includes infrastructure like road and rail, and then cadastral boundaries, and then cities and towns, and some settlement location and hydrological boundaries, water bodies. So all this is shown in this. You can see all this data in ISRO's geoportal. Now, next, Survey of India. Now, Survey of India, you must have heard about this Survey of India, is it not? आप लोगों ने सुना होगा Survey of India. It has its headquarters in Dehradun. Okay, and this comes under Department of Science and Technology, Ministry of Science and Technology, and Survey of India from last I think 200 years or what. It has been engaged in the production and maintenance of various kinds of topographical, geographical maps and many public series They provide CDs also nowadays, and sorry, they provide these a lot of free data is available on this Survey of India portal of various different scales, and this all this data are used for defense and the development of nation. And you can access digital vector data of administrative boundary database like district, taluka, and village levels. And you can use this data for geodetic and geophysical surveys to study seismicity and then glaciology. This data is used for glaciology programs and many other things at different scales. Now, next, NATMO, that is National Atlas and Thematic Map. You know, this NATMO, it has its headquarter in Kolkata. Okay. And this is also it comes under Ministry of Science and Technology. If you are based in Delhi, whenever you go on this Department of Science and Technology, which is situated on New Mehrauli Road, as you enter the gate, you have this NATMO office wherein you can get these maps, NATMO maps, like resource maps and many other kind of data which you require. You can get at a very nominal payment, hard copies, soft copies you can get. Okay, so I mean, it publishes atlases at many scales, smaller scales, and this NATMO. This is only the agency in the country which caters to the requirement of thematic maps and atlas at different sectors. And you know, it is one of the largest repository of spatial and non-spatial data, and the data is available with great accuracy. Okay, next. I hope you are following this. I'm very sorry because of my this viral fever. Anyway, next one is Geological Survey of India. So GSI is also one of the oldest survey organizations in the world, and it is devoted to earth science studies. And I forgot to tell you, basically, we all in the program team, DGI, MSc, PGCGI, in these program teams, we all are geologists. So very often we use data from Geological Survey of India for various uses. So this GSI, it is the custodian of geoscientific database, I think, for over 200 years. And all these products of GSI, they are in the form of different memoirs, records, journals, bulletins. So if you access to Geological Survey of India, you can get all these memoirs at cost. I mean, they're all some of the things are free, but not all. These memoirs and records and journals you can get from GSI portal, and they have mapped the entire country at 1:50,000 scale for entire India. And there is one gateway on this portal, Geological Survey of India, which is known as Bhukosh. And this Bhukosh, it is the gateway for all the scientific data they have there, and this data is freely accessed at Bhukosh. And this data, you know, it is related to various themes in geology, geomorphology, geochemistry, geophysics, seismotectonics, landslide inventory, meteorites. In your SLMs, there is one link given so you can freely download it. Next one. That is FAO Geo Network. This FAO Geo Network, it has variety of thematic FAO Geo Network. It has variety of food and agricultural organization इसका full form है, and उसमें you get variety of products which you can access through the link provided in your SLMs. And it provides internet access to interactive maps, satellite imagery, and related spatial databases. And then the next one, which you will discuss, see, I'm discussing in very short. And if you want to go into more detail, you can go to your SLMs, can read them. Then ESRI, ARC GIS Hub. So this hub is easy to configure community engagement platform, and it organizes people, data, tools through information driven initiative. So government agency, non-profit groups, academia, they can engage or they can collaborate and they can share using this initiative. Next one is natural earth. What is this natural earth? It is public domain map data set that is available as at 1:10 million and many scales. 1:50 million, 1:110 million. So this data is available at this different scales, and you can make variety of you can get variety of information with the various kinds of maps at various scales. Then other sources also are also there, which I will not go in. I mean, but okay, Diva GIS. Diva GIS, this provides free spatial data for whole world, either in Diva GIS platform, this one, or other platform. It is free computer programming, a program for mapping and geographic analysis. So you can create maps of the worlds or any other small area map. For example, state boundary, river, and this vector data, they are stored as ESRI shape files, grid data, and each shape file, it consists of at least 3 or 4 actual files. So now rest of the I'm leaving. Now from where do you get the geospatial data? See this table 6.1 in your SLMs. ये पूरा 22 states का data you can get from these. These are the centers address है. Himachal Pradesh, Jammu Kashmir, Jharkhand, Karnataka, and then here Madhya Pradesh until 22 West Bengal. So you can get all these data of all these states from this address has been given there, and email also has been given there. You can get all this. Okay. So this was about getting the data or obtaining the data. Now, next. There are many other links that have been mentioned in your SLMs. You can go through. Now, next one is data quality issues. We have talked enough about the data. Now, what are the data quality issues? See, earlier also I discussed when I was discussing about the caution in downloading the data. Now, data quality is the major concern. So you should be aware about the limitations. You should be aware about the administrative boundaries and terms and conditions for usage, and then copyright and other things which I have already discussed. And you should be aware about the limitations in the methodology, all these things, and then or there may be discrepancies and inconsistencies in the data, some errors. So you should be aware of this data, and accordingly you should download the data depending upon the interest. Now, next one is Geospatial Internet of Things. What IoT? So this term IoT is very often used, and nowadays it's a buzzword. So what is IoT? IoT, see, it sort of integrates everyday things in with the internet. Okay, and IoT, it can be referred as the collective network of connected devices and technology which facilitates communication between the devices and the platform and amongst all the devices. So typically there are three components on IoT systems. Smart devices like television, security camera, then IoT application, which is the collection of services and software that integrates data received from various IoT, and then graphical user interface to manage IoT devices. So these are three components. So this was all about Unit 6. That was raster data. Now, again, PGCGI students, they have got only one unit in their SLMs, that is data analysis tools. But for BGI learners, since we have upgraded that PGCGI into DGI and MSc program, actually PGCGI program was running since last 2014, and now it has been upgraded to DGI and MSc GI program. So things have been upgraded according to the present state of knowledge available. So you have only one unit there, but now this has been divided into two units, unit 7 and 8. That is part 1 and part 2. Part 1 that deals with commercial off-the-shelf software, that is COTS, commercial. And part 2 deals with FOSS, that is free open source software, that is known as FOSS. So part 1 is commercial off-the-shelf. We will discuss about commercial off-the-shelf software, its usage and functionality, advantages of COTS, and various other COTS software that are available like ArcGIS, ADAS, NV, and then indigenous geospatial software, and then what are the hardware requirements and SWOT analysis, all these things. So your learning outcomes are given here. You can, so to start with, what is the data handling tools? We say data handling tools. What are they? They are they are not any hammer or some shovel or spade. They are simple software or software packages which help you in handling geospatial data. Okay. Very quickly, I'll not. There are many slides on this. So basically, it is a software that comprises an integrated collection of software programs that implement geographic storage and processing and display function. And what are the functionalities of these geospatial softwares or geospatial tools? They allow you to study the data, methods, and algorithm implementation. They help you in developing model and algorithm need not be implemented by others, and they ensure worldwide development and advancement and application. I'll not go into historical developments of all this. So how do you define as modern geospatial tool? It comprises of an integrated suite of software components of three basic types. data management system for controlling access to data, mapping system for display, interaction with maps and other geographic visualization, and a spatial analysis and modeling system. Okay. Now, these are the key parts of GIS: architecture, the user interface, business logic, data manager, data model, customization. This is all very theoretical. And what is license? License is a product of allowing an individual or a group to use a piece of software. Most of the applications are licensed rather than sold in geoinformatics models market. So this is about license. COTS, as I told you, the software which come under the category of license in which user must purchase to run or upgrade the software, they are grouped as COTS. And there is another type of licensing system that is known as general public license. So this is used for the kind of software known as FOSS, which is the next unit, free and open source software. What do you mean by open software? It is a software that has source code that is freely available, downloadable, and is licensed. It is freely distributed. As I think yesterday, Professor Deshmukh, he must have told you about QGIS, which you must have downloaded for your practical, exercise purposes. So what are the advantages of data analysis tools? It allows you to map the location of the object like natural and human resources. Terrain models can be generated to aid with 3D visualization. Densities and quantities of specific terms in a given area can be calculated and displayed. Okay. Advantages I will not go because still we have to cover. I will come into this. These are the hardware requirements for geoinformatics system. You have a certain speed of CPU speed, then processor, then memory, RAM, and then display properties. All these things are given in your SLMs. Then screen resolution, swap space, disk space, video graphs, fixed adapter, networking hardware. So these are all hardware requirements. Next. It is very important to you to know how you select your software. First of all, you should know about your budget, how much you can spend, your experience, and the task which need to be performed. Okay. So I've already told you. So commercial of the self software, that is COTS, it is economically viable method of integrating various software components to produce a new system, a new product. Okay, this we have been discussing. Let me come to other types of COTS geospatial software. Actually, it is 12:47, so I just have to rush through. Yeah, examples of core software. See, many core software are available in the market. I will just discuss few of them. Let me come to ArcGIS. This was developed by ESRI, and it is a comprehensive geospatial platform. This offers a wide range of tools and capability for data management, analysis, visualization, and mapping. So it includes desktop, web, and mobile application, as well as server-based components for publishing and sharing geospatial data. Okay, so it is the one of the widely used geospatial data analysis tools by academia and industry. Then the next one, that is ADAS. In your SLMs, the details about ArcGIS is given, its components, its functionalities. Now let us come to ADAS Imagine. That is, it is a raster graphics editor which is capable of geoinformatics application. So this COT software, it primarily focuses on processing geospatial raster data, and it enables users to produce, show, and analyze digital images for usage as maps in GIS or CAD software. And this also enables the user to carry out variety of operations on an image and produces answer to various geographical queries. So similarly, you have map info and other software also which have been NV. NV is also one of the software, that is environment for visualizing image, and this is used to process and analyze geographical information, and this is promoted by ITT, that is ITT Visual Information Solution. So now further, indigenous software also there we have, that is gram plus plus. This supports digital vector data format, and this is used by Survey of India to improve its usability in Indian settings. Okay. Now the quickly into SWOT analysis of this. There is one more indigenous software, geospatial software, which is given in your SLMs. This was developed by ScanPoint Geomatics Limited in collaboration with ISRO, and it is considered as cutting-edge platform with bringing together GIS and this image processing, photogrammetry, and CAD on a single platform. Then quickly looking at the SWOT analysis of quartz. Its strength are research and development investments, customer support infrastructure. Now, weaknesses are it is closed source, it has closed source code, and it is expensive to upgrade. Threats are lock-in effect, security weaknesses, and opportunities are you have innovative new products which can be updated. So the next unit is Unit 8, that is Geospatial Analysis Tools Part 2. In this, we have, as I told you, you have FOSS, that is free open software. It has, in this unit, you have contents like usage and functionality, advantages, overview of various FOSS geospatial tools like QGIS, which you are using, Saga, GRASS, which you will be using, ILVIS, Whitebox. So all these have been discussed about different geospatial tools. And then you have comparison of various FOSS software, and then hardware requirements for FOSS, and SWOT analysis for FOSS geospatial software. So these are the learning outcomes. As we have already discussed, FOSS, that is free, open, or it's also known as FLOSS, free library open source software. This is liberally licensed to grant the right to users to use, change, improve its design through availability of its source code. So all the exercises in your labs, they are being done using FOSS software, free open software. Regarding its usage and functionality, They have marketable skills, support by huge development and support community, low startup cost, security, workability, and works with existing GIS data. Then view and overlay, create maps, edit and export, spatial analysis. These are the examples like QGIS, then GRASS, and then Saga, which I think very hurriedly in 2 minutes we can go through because it's already 12:55 and we have one more unit that is on programming. So QGIS, it is capable of open source free geospatial software, that is quantum GIS. Then next one is Saga. Saga, the full form of Saga is System for Automated Geoscientific Analysis. And this one is considered as one of the classic in-force geospatial software. And this is designed for effective and easy implementation of spatial algorithms, and it offers comprehensive growing set of geoscientific methods. So this software is basically used for terrain analysis like hill shading, watershed extraction, and next one. Next, we can GRASS. You will be using GRASS also in your exercises. GRASS ka full form is uh, Geographic Resources Analysis Support System, GRASS. So this is referred as commonly referred as GRASS. And again, this is free and open GIS software, and it offers powerful raster, vector, and geospatial analysis tools. Okay, and I think I just skipped. So there are many benefits of this FOSS. It is inexpensive, and it avoids government agency getting locked up into commercial supplier, all these things. And QGIS, I've already told you, GRASS, and then ILWIS also. ILWIS is Integrated Land and Water Information Management. This was once a commercial software, but now this is open source. And this has been developed by International Institute of Aerospace and Earth Sciences, ITC Netherlands. So it has good capabilities of both GIS and remote sensing and analysis, and it is quite versatile and very good at digitizing, editing, and displaying geospatial data. This I will skip, it's given in your this thing. Now, what are the system configuration of various software? There you have a table there where you have different system configuration for different software which are listed in your SLMs and which we have discussed. I need not go into detail. And then for lastly, let's come to SWOT analysis of FOSS. This is source code is freely available. It is free for use and modification and no lock-in effect. These are the strengths. And weaknesses, that depends on the community fund and slow, and it's very slow in development. Threats, mismanagement of the fund contributed, and opportunities, possibility for new variants of software and new analytical tools. It has, these are the opportunities. Now, the last unit of this, see, PGCGI students, they don't have this unit. So this is only for the DGI and MSCGI students. The last unit, that is unit 9, overview of geospatial programming languages. We don't have much time left to discuss this. And yeah. This unit, it provides you overview of various programming languages which are listed as shown on the screen. C, C++, and others which have been listed here. And then you have comparison of various languages. And then you have system configuration requirements that are required. So all this comprises the part of this unit 9. Very quickly, the popular programming language which are used in the geospatial systems are listed here. C++, C, Java, Julia, and then PHP, Python, R, Scala, SQL, all these are listed here. These are the popular ones. And all these softwares which are used to for these geospatial application like ArcGIS, they are based on programming languages like ArcGIS. It's written in C++. ENVI, it's written in IDL. GRASS, that is written in C, C++, Python, and ILWIS in C++, and then QGIS in C++, Python, and Qt. So these are the various languages, and all these softwares, they are written in certain languages. Okay. That's why you need to have a basic understanding of the programming languages. And all this has been listed in your this thing, and this has been listed. And then in this particular unit, there are tables which give you the comparison of the different programming languages and their, advantages and disadvantages, how useful they are, and in what way they are this thing helpful. So all this is mentioned here. For MSc GI students, you have more detailed units on, excuse me, on Python and R languages in your third semester. Okay. So I think I will, because your next session also starts. You have, after this, you have a break. Rohitas, are you there?
Yes, ma'am.